Iceland is one of the most volcanically active regions on Earth, and this activity is directly linked to its unique geological setting. Unlike most volcanic regions, Iceland lies at the intersection of a divergent plate boundary and a deep mantle plume. The mid Atlantic ridge passes through the island, separating the North American and Eurasian tectonic plates, which are slowly moving apart. At the same time, a rising mantle plume supplies additional heat and magma from deep within the Earth. The combination of a plate divergence and plume activity makes Iceland an exceptional natural laboratory for studying volcanism. Volcanic activity in Iceland is dominant by basaltic magma, which is low in silica and therefore relatively fluid. This type of magma allows gases to escape easily, resulting in eruptions that are often effusive rather than explosive. Lava commonly flows peacefully across the surface, forming extensive lava fields and shield volcanoes with gentle slopes. However, not all eruptions in Iceland are quiet. When magma interacts with water, ice, or snow, explosive activity can occur, producing ash clouds and fine volcanic particles. One of the most typical features is the strong interaction between volcanoes and glaciers. Large parts of island are covered by ice caps, and many volcanoes are located beneath them. When an eruption occurs under a glacier, the intense heat rapidly melt ice, producing large volumes of melt water. This can lead to sudden and destructive floods, which can reshape landscapes and damage infrastructure. Iceland volcanoes occur mainly along volcanic zones that follow the mid Atlantic ridge. These zones are characterized by fissures eruptions, where magma rises through long cracks rather than a single central vent. Some of the largest lava flows on Earth have been produced by such fissure eruptions in Ireland. A famous example is the Laki eruption in the late 18th century, which releases enormous volume of lava and volcanic gases over several months, causing environmental effects across Europe. Although basaltic eruptions are most common, Iceland also hosts more evolved volcanic system capable of producing explosive eruptions. Volcanoes such as Hekla and Katla have shown both offensive and explosive behavior. The 2010 eruption of proved how volcanoes can have global impact. Fine ash produced during the eruption was carried by atmospheric wind across Europe, leading to widespread disruption of air travel and highlighting the importance of volcanic monitoring and hazard assessment. Volcanoes in Iceland represent the dynamic interaction between Earth's internal processes and surface environments. They provide valuable insight into mantle dynamics, plate tectonics, magma generations, and volcanic hazard.